In this video, we will use your TI-84 to find the points of intersection of two curves. So for our example, let's look at the curves defined by these functions, y equals x squared plus 2x minus 15, and y equals x minus 1. Now again, I have no doubt that you could find the points of intersection of these two curves using algebra. You would just take the two functions, set them equal to each other, and use basic algebra rules. And solve that equation. And in fact, that's one way you could do this on your calculator. You can turn the intersection into an equation where you are finding the zeros of a function, or, in terms of the graph, finding the horizontal intercepts. So you could enter this new function into your calculator and find the zeros, as we did in a previous video. But let me show you the intersection command on the TI-84. So let's enter our functions in. So we go y equals, and remember our functions are x squared plus 2 times x minus 15. That's our first function. And our second function is just x minus 1. And we want to graph these functions. And you can see the first function comes up first, and then the second function comes up. So you can see the points of intersection. Now do keep in mind that you may have to change the window to see all the points of intersection. Now we happen to know that we have a linear function and a quadratic function. There's our quadratic function. And there's our linear function. So we do know that we are seeing all the points of intersection, but again, keep in mind you might have to change the window to see where your functions actually intersect. Okay, so how will we do this? Well, just like most things working with graphs, we are using the calc button on your calculator. It is a raised key, so we have to use the second key first. Should be used to that by now. So second calc, and we are using option 5, intersect. So again, you can either use the arrow keys to scroll down to 5 or just press the number 5. Now the first thing the calculator asks you is what curve do you want to use for the first curve? Now there are only two curves here, so it doesn't matter which one we use for the first curve. If you want to change back and forth between the curves, you use the left and right arrow buttons. I'll just use the first curve as the first curve that comes up, so I'll just press enter. What do I want to use as the second curve? Well, we'll just use the other curve they give us, so press enter. Now we want to guess where the point of intersection is. Now we can either just type in our guess or use the arrow keys to get close to the guess. I'll use the arrow keys this time because we're not that far away. So as you can see, I'm moving to the right to get close to the point of intersection right here. You can see the cursor flashing there. So I'm fairly close, so I'll press enter. And you can see the point of intersection there. So let's see if we can write that down. 3.2749, let's call it. So from this answer, it does not look like a nice fraction. So it probably involves a square root with the quadratic formula. Okay, so that's the x component of the point of intersection. And the y component, let's call that 2.2749. So there's one point of intersection. Now there are 2 points of intersection. You can see one down there. So let's find that one. So we just do it again. Second calc. Option 5, intersect. Again, for the first curve, I'll just take whatever they give me for the first curve, so I'll press enter. Same thing with the second curve. The only time this really matters is if you have more than 2 curves on your screen at one time. Then you'll have to be careful deciding which curves you want. So I'll press enter. Now I want to guess. Now again, you can use the arrow key to scroll down to where we think the point of intersection is. This time I'll just guess myself. So let's see. 1, 2, 3, 4. So it looks to be about -4. So let me just type in -4 for my guess. Enter. And again, it gives us the point of intersection, or at least an approximation of it. Let's call it x equals -4.2749. And let's find the y value. -5.2749. Now you'll notice all these numbers look similar. And that has to do with the exact answer. So why don't we do that? To find the exact points of intersection, remember we reduced our equation here. We set the 2 functions equal to each other. We reduced it to this second equation, x squared plus x minus 14 equals 0. Now it doesn't look to me like that factors, because the factors of 14 are 2 and 7 and 1 and 14, and neither one of those will give us 1. So let's use the quadratic formula. So the opposite of b, 2 solutions, 1 plus, 1 minus, square root of b squared minus 4 times a times c. So minus 4 times a is -4, and then -4 times minus 14, that's where the plus comes from. So that looks like 56 all over 2 times a, or 2. So x is equal to -1 plus or minus the square root of 57 over 2. So there are 2 x values. You can tell that the +1 is that, and the -1 is that. So because they both involve the square root of 57, that's why all these decimal values look close. Because when you plug this x into the function to get the y value, it will still involve the square root of 57. So that's why all these numbers look similar. But in any case, that is how you use your TI-84 to find the points of intersection of 2 curves.